physician, scientist, searching for a way to tap into the hidden strengths that all humans have. Then an accidental overdose of gamma radiation alters his body chemistry. And now when David Banner grows angry or outraged, a startling metamorphosis occurs. The creature is driven by rage and pursued by an investigative reporter.
Mr. McGee, don't make me angry. You wouldn't like me when I'm angry.
The creature is wanted for a murder he didn't commit. David Banner is believed to be dead, and he must let the world think that he is dead until he can find a way to control the raging spirit that dwells within him.
Don't make me angry. Watch the video. Don't make me angry. Just a question on shear force and bending moment with an overhang. It's got two forces. It's got two forces. 6 and a 4. There's my overhang. We've got to draw shear force and a bending moment diagram for this beam. 3 there, so it's 6 to there, 2, 4 and a 6, and there's 2 reactions, and we're ignoring the weight of the beam, so there's no UDL. First of all, work out these two as normal with beams. So for force times distance is the moment. We'll assume all moments add up to 0, all forces add up to 0. Clockwise positive, anti-clockwise negative. So we'll calculate RB first, and all we're doing is, that's the pivot point, so the 6 goes that way, the 4 goes that way, and the RB come this way. So we've got the 6 times by the 3, the 4 times by the 8, and then RB times by the 6. Positive, positive, anti-clockwise. So there we are. 6 times by 3, 6 times by 3, going that way, positive, positive. 4 times by 8, 6, 7, 8, 4 times by 8, also going that way, positive. 4 and 8, 4 and 8. The RB is coming up, so the RB is going to be going that way, which is anti-clockwise, hence negative. We don't know what RB is, but we know it's 6 meters away. It's 6 meters from there to there. All that's got to equal 0. So put that in there. I brought the negative bit over to make it positive. So if we put that in your calculator, 6 times by 3 plus 4 times by 8 gives you that. Divide it by the 6, so 50 there. Bring out this, bring it over, make it positive. Therefore, RB is 50 over 6, so divide that by 6. Dun, 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 dun. 25 over 3, which is 8.33, recurring. So you could use that in your further sums because it's a bit more accurate, but 8.33 recurring. Then to calculate RA, you then just go the other way, take moments about that point. Same process, so we've gone through there. Whereas this way we've got, let's get rid of all this. Same process. So with this one, we're doing, that's my pivot point now. Pivot point is there somewhere. RB, so now we've got 4 going this way, so 4 is going to be positive, 6 is going to be negative anti-clockwise, and RA is also going to be clockwise. So it's 4 times 2, 6 times 3, and RA times by 6. 4 times by 2, 6 times by 3, 4 times 2, 6 times 3. One's going clockwise, one's going anti-clockwise. Plus, negative, and then RA times by 6. Do all of that, and you work out that RA is 1.6666 kilonewtons. It's recurring, so 10 divided by 6. So that's the proper way of doing it. And obviously you can check, because we know that the sum of the forces equals 0, so what comes up will go down. So RA plus RA plus RB has got to equal 6 plus 4, because there's RA and there's RB coming up. And there's 6 and 4 coming down. So 1.6 plus 8.3 gives me 10, which is correct. So there's my reactions. I mean, the quick way of doing it is that, and it's like we used to do. So we know that RB is 8.33, and you know there's 10 coming down. So 10 take away that gives you that. The problem to do it that way is, if that's incorrect, then the rest is going to be incorrect. So it's best to do it both ways. Check yourself. There's the reactions. Now we're going to do shear force calculations. So, nice and easy. 6, 4, 8.3, 1.6. We start from the left. So we're looking at shear forces. So at x equals 0, all we can see is 1.667. All we can see if I can draw this. No, I can't. Can I put a shape in here? No. So we just look from the left. So at x equals 0, all I can see is this force here, 1.667 coming up. X equals 3, I can see that force coming up. I can also see that force coming down. So that, take away that, gives me that, 4.333. X equals 6. I've got another force there, so I'm going to go there. I've got minus 4.33 now. And I've also got 8.33 coming up, equals 4. So I've got 2 points at x equals 6. I've got that point, and then I've got that coming up, which gives me that. X equals 8. So I've got 4 from before, but I've also got the 4 right coming down. So I've got 4 take away 4 is 0, comes down. X equals 10, don't forget it should be back to 0 there, so to make sure everything's okay. I've got 1.667, which is that. I've got take away the 6, plus the 8.33 coming up there, and take away the 4. All that will give us 0. If it gives you very close to 0, it's just because we've rounded up. So it's all 0 at the end. So that's my shear force calculations like we've done before. Just look at what forces we can see, and then we plot the points on the graph. So there's my first point, 1.667, which is there. So I've got 0 and that. So it starts off 0 straight up to 1.667. Then it comes across, I've gone to x equals 3, because there's no weight to the beam, so it's nice and easy. At x equals 3, I've got 1.667 and minus 4.33. So 1.667, and it comes down to minus 4.333. So there's my lines with across. There's no weight to the beam, so there's nothing to worry about. Comes down 6 to minus 4.333. Don't forget, where across is 0, that's where 0 shear force is. So there's 0 shear force at x equals 3. And then I've come across x equals 6. I've got minus 4.3 plus 4. 2 points again. Come across to x equals 6, so I've got minus 4.33, and I'm adding on that reaction, which is that. Gives me all up to 4. There's my 4. Line up. Because we've got an overhang, we've got 2 points now, 0 shear force. So there's another point of 0 shear force there, x equals 6. And then the next force along is going to be this 4 coming down. So there, x equals 8, I got 4 coming down. And then that's the last force. So x equals 8, I got 4 and 0. So 4, take away 4 down to 0. And then at the end, all the way to the end, to 0. So there's my shear force diagram, positive, positive, positive shear, negative shear. I've got 2 points now with a 0 shear force. So I'm expecting these places to be high points on my bending moment graph. That's my shear force. Labelled there, look, kilonewtons, labelled there, title. My next one, bending moment calculations. Again, start from the left, and all we're doing is doing force times distance. So at x equals 0, that's my force. I'm only there, so that times that gives me 0. I've now come in x equals 2. At x equals 2, which is about there somewhere, all I can see is 1.67 times by 2. Gives me that. X equals 3. Now from this diagram here, I'm expecting x equals 3 to be top of my bending moment diagram curve. And I expect 2, 1 at 3, and 1 at 6. X equals 3, I've got that point there. So I've got 1.6 times by that. Obviously I'm underneath that, so I can't see it. So 5, I'm expecting this to be my biggest positive, because it should be, because it's 0 shear forces. X equals 4. I'm here somewhere. So 1.6 times by 4, and now I've gone past that 6. I'm 1 meter past it. I'm 1 meter past it. So that, take away that, gives me this. So it's coming down now. So like I said before, 0 shear force, maximum bending. So at x equals 3, I've got my maximum bend there, look. It's now coming down. So carry on going. X equals 5, I've got 5 meters of it. X equals 5 here somewhere. That times by 5, and that times by 2. So now I've got underneath, because it's an overhang, so I can get positive and negative bending moments. And then I just keep going, x equals 5. So what's up now? That's going up, that's going up, that's going up. So plus 1, and that's just coming down again. X equals 6. At x equals 6, I had a position of 0 shear, so I'm hoping that this now is going to be my biggest point in my negative bending. So up by 1 gives me minus 8 really. That should be my highest number, because that's my biggest positive shear, and this should be my biggest negative shear. Keep coming, so up by one, and now I've gone 7 meters, so I'm here now, so I can see this force. So there, I'm 1 meter past it. So it is coming down. So we've gone past, that's our biggest point, and now it's coming back up. So we've just gone +1 there, and now I've gone past that. So I'm 7 meters in, which is here somewhere. I'm 1 meter past this force. And then keep going, so +1, gets me down back to 0 now. So it's coming back down to 0, which it will, because no UDL. X equals 10, right, so at the end of the beam it should equal 0, so +1, and now I'm 2 meters past the 4, because I'm there, so I can see this. So all that equals 0, everyone's a winner. So now plot on the graph like this. So there's my points, 3.3 and 5, 3.3 and 5. Then I've got 0.6 and 3.6, 0.6, 3.6. We're coming down now, so it's come up. So this is positive bending, negative bending. With an overhang, it does that, okay? Without any overhang, it just goes like this. If you remember, it just does this. But with an overhang, it does that. So I've got an overhang, crosses there. This point here is x equals 3, which is the same as there. And x equals 6 should be here. So biggest negative, biggest positive. So plot these numbers. There's my 8. There's my 8. 3.9 minus 3.9 minus 3.9, and then back into 0. So our maximum positive bending moment is at x equals 3 from the left, and our maximum negative bending moment is at 6 meters from the left of the beam, which ties in with this, because 0 shear force, maximum bending, 0 shear force, maximum bending. This point here is called the point of contraflexure. It's the point where it goes from being positive to negative. So on your graph, it's just about there somewhere. Wherever it crosses there. In our case, about 4. So the point of contraflexure is 4 meters from the left. I would suggest you plot both graphs on the same graph paper so you can do this. So do the shear force up here and do the bending moment down there like that. Because you can then check to see if this point lines up with that point, which it does. Maximum bending, 0 shear. Maximum bending, 0 shear. So then you can draw that to make sure that your numbers align. So maximum positive, maximum negative, and the point of contraflexure. So that's a quick example of how to do an overhang with 2 forces, no UDL. Don't forget you have to encounter the UDL if you've got one. Like I say, with an overhang, you're going to get 2 points like that, and you'll get 2 points like that. You'll get a curve like that, and that point there is the contraflexure. So any problems, let me know, and yeah, make sure you watch The Incredible Hulk, the original version.
Dr. David Banner, physician, scientist, searching for a way to tap into the hidden strengths that all humans have. Then an accidental overdose of gamma radiation alters his body chemistry. And now when David Banner grows angry or outraged, a startling metamorphosis occurs. village and pursued by an investigative reporter.
Mr. McGee, don't make... You wouldn't like me when I'm angry.
The creature is wanted for a murder he didn't commit. David Banner is believed to be dead, and he must let the world think that he is dead until he can find a way to control the raging spirit that dwells within him.
Don't make me angry. Watch the video. Don't make me angry. Just a question on force unbending moment with an overhang. It's got two forces.